We present GenVDM, the first method for generating vector displacement maps from single image. Despite rapid advancements, generative neural models for 3D shape synthesis are not widely adopted in artistic workflows. This is primarily due to two issues. First, these models struggle to synthesize fine geometric details. Second, they lack the precise spatial and compositional controls that artists require. Consequently, tasks easily accomplished in traditional workflows, such as adding detail to a human head in Maya, ZBrush, and Blender, remain challenging with generative models. To address these limitations, we adopt an existing workflow where artists enhance a base mesh by stamping details onto its surface using vector displacement maps, VDMs. A VDM is a map that assigns a 3D displacement to every point in a 2D rectangle, which can be applied to an arbitrary UV region of the base mesh to create complex geometric details. Compared to scalar displacement maps, VDMs can express more intricate geometric features, such as overhangs and cavities. VDMs are widely used in artistic workflows to create part-level details of specific categories, such as nose wrinkles, ears, fur, scales, and horns. While commonly used, authoring VDMs is an extremely challenging and exhausting process. This raises the question, can we generate VDMs from simple inputs, such as a single image? In this work, we propose GenVDM, the first neural pipeline for generating VDMs. Our model takes a single RGB image as input and outputs a VDM. The generated VDM can then be applied to a base mesh to create geometric details. In Blender, users simply need to load a base mesh and the generated VDM images. Using the sculpting mode, users can select regions where they want to apply the VDM using a brush, then draw down to extrude the VDM onto the base mesh. Users can also control the strength and orientation of the extrusion with a mouse. Importantly, the topology of the mesh remains intact, as only vertex displacement is involved in this process. This approach was used to create the teaser image for our work. Generating VDMs from a single image involves overcoming two main technical challenges. The first challenge is that existing generative models are not suitable for VDM generation. Shapes generated by existing generative models lack a parametric 2D domain, making it difficult to combine with a base mesh. To address this, we develop a three-step pipeline. Firstly, given an input RGB image, we predict normal maps from multiple viewing directions to resolve occlusions that may be hidden in a single view. We then reconstruct a mesh by fitting a neural sign distance function to the multi-view normal maps. Third, we use a neural deformation model to displace points on a 2D rectangle to fit the mesh, forming the final VDM image that can be applied to the base mesh. The second challenge is the absence of training data. To our knowledge, there are no publicly available VDM datasets suitable for neural network training. We address this by building an interactive tool to segment interesting semantic and geometric regions from Objaverse 3D models. We analyze the segmented parts and remesh their geometry into single connected surfaces with disk topology. The resulting meshes are then deformed to obtain coplanar boundaries, allowing them to seamlessly attach to a flat base tile, as required for defining VDMs. These processed shapes can then be rendered and used to fine-tune the multi-view normal generation model. We created a dataset of 1,200 shapes for training. We compare our results with the state-of-the-art shape generation techniques and demonstrate that our method outperforms them both qualitatively and quantitatively. Please refer to the paper for detailed evaluations. With our image-to-VDM model, users can edit in 2D image space and change the appearance of parts in 3D. Editing in image space is typically much more convenient than sculpting 3D shapes, enabling users to customize parts easily. Thank you for watching.